Hey everyone, Natasha here from the Immerse team. Today we are going to be running through some code that will help you create some great visualizations that will help you best convey your latent class findings to your audience. These figures and tables are APA style, so they also would be really great to include within a manuscript. So some of these tables are going to include how to create a table for your variables, some descriptive statistics along with class information. And some of these figures that we are going to be creating today will help you display some information criteria that you went ahead and found throughout the enumeration process, along with how to display your probabilities for that optimal model. All right, so let's get started. Now, if you're watching this video and using this code that we have provided here, you must have already gone through the enumeration process. If you have not, don't worry. The MERS team has already created a series of how-to videos to help you get through the enumeration process. All right, so let's continue then. Since we are building upon our previous videos, we are going to still use our bullying in schools example. Data are from the civil rights data collection, and we have specifically used 6 dichotomous indicators to distinguish school-based bullying. 3 indicators here are actually reports suggesting that a student or students had filed a harassment report at a school in a school district on the basis of disability, race, and or sex. The remaining 3 items note whether there are counselors, psychologists, and law enforcement on campus. All right, so the first line of code that we want to go ahead and run here is we want to run and load all of these packages. We are going to be using today Tidyverse, Haven, M+ Automation, Janitor, GT, Cowplots, Diagrammer, and JTool. If you need some more information on these packages that we are constantly using, please go ahead and find some of that information in the description below. All right, so our first line of code that we are going to be running today is going to help us prepare our data by reading it in. So that actually starts on 152. And so we are reading in a CSV file using the read_CSV function. Our data is specifically in a data folder, and then it is called CRDC_LCA_data. Another thing that we're doing to the CSV file is that we're going to be cleaning up our variable names by using the clean names function. So what this is actually doing is creating uniform names. And what I mean by uniform is that it's making them all lowercase, for instance, just a little more visually appealing, rather. Along that, we are using the Dippler package to use the select function because we only want a couple of variables here that we want to use. All right, once we went ahead and did that, we went ahead and then had a df bully data set in our environment here, and this is what it looks like. Those are those 6 variables that we are interested in. All right, let's continue on. Let's create some cool visualizations to display some proportions. And how we're going to do this is that we are going to be using a pivot table. And so what this pivot table is going to do is that it's going to help us display our proportions per each variable here. And we're using the pivot longer function. And we're concatenating the 6 variables that we are interested in. And we are also wanting to create a new column with these 6 variables that will now become their own row. And that new column is going to be called variable. So let me show you what is actually happening here. So DS is now our pivot longer. And so one more time, what happened was that each one of our variables that were once in columns now becomes its own row with then a value. So for instance, a 0 indicates that no harassment report was filed in this case. And then a 1 may suggest that yes, that a counselor was on campus. Okay, let's continue. And then from there, we're going to create a table of our variables and counts. And we're going to find our proportions, and we are going to set those proportions to 3 decimal places. So one more time. Here is a function to help us get those counts for our variable, and there's the value. We're going to be grouping by variable. And then we're going to be gathering our proportions using the mutate function. And then we're going to also use the mutate function to then round those proportions to 3 decimal places. All right, so let me show you what this prop table looks like. Let's see. All right, so one more time. Each one of our variables is now a column, and now they actually have the value and the proportion for those values. So one more time here. We have a value of 0 suggesting that no students had reported that there were counselors on campus, and the number of those schools were 1,081, and this is a proportion for that. And then for those schools that actually had a counselor on campus, 919 suggested that, and then this is the proportion of those. And then you also have some missingness in this data set, and that's what the NA stands for. All right, so let's continue. So now what we're going to do is we're going to take this prop df table and we're just going to make it nice using the GT function. And it's just going to be just a little more appealing. And maybe you can possibly use this for a manuscript, or you can even create something just different, but this will just help you really visualize it. So specifically, we are specifying that the variable name in rows should have their own columns. Okay. And then we are noting that the variable values 0 and 1 should be their own rows. We also provide title headers using the tab stub head function and the tab header function. MD is actually a function that will help us tell R to read in whatever's in quotes as an R markdown formatted text. Then we go ahead and we modify the tables to make them more presentable using column labels. So now, for instance, our variables will now have a title that suggests variables, but it has capitalization. Values, same thing. N will then be a capital N for that title name, and proportion will actually read proportion. Let me show you what this table looks like. Let me run this. And let me print. And so then you can see here, this is what our table looks like. This is what we just created. And now if we want to go ahead and save this nice table here, we need to go ahead and use the GT save function. And so we are going to specifically save this table into a PNG file. And so we are calling in its name that we previously created. We are then suggesting that we want to save this PNG into our figures folder that has already been pre-created. And then also we are assigning this table a new name, and that's going to be prop_table.png. It is very important that you add that extension. If not, it will not be a PNG file. All right. And so if you want to go ahead and save this table into a .docx or docs, what you need to do is one more time, use the GT save function. You're calling in the table that you want to then convert into a doc. And so you're using the here function to note that you want your table to be saved in a tables folder that you had already created, and it's right here. And then from there, you want to go ahead and state the name of that new document along one more time. You must put in the extension. And in this case, since we wanted a document, we're putting .docx for doc. Next, let's create a table for our fit statistics across each step of the estimated classes during the enumeration process. First, let's extract the data using the read models function, which is from M+Automation package. Using the here function, we are suggesting that our models are in the enumeration folder that was previously created. And then the file filter function suggests that all of the bully files need to be read in and analyzed. Since we're using the quiet argument here, we're suggesting that not to show any status messages in the console. Sometimes I think it's actually useful to go ahead and suggest false, so that way we can go ahead and display our output in that console. Right. So we have called that in by running line 211. Bam. And so let me show you what that looks like real quick. These are all our output files that are titled with bully in them. Okay. Next, let's go ahead and create a summary table using the LaTeX summary table function from M+Automation. And this is just going to help us create a LaTeX formatted summary table of model fit statistics extracted using the extract models summary function that we just used. The first argument in this function is the list of models which we assign to the output bully. Okay. And so from there, we're going to then specify a vector of character strings, which are going to indicate the columns we would like displayed in our summary table. Now, we want to be very specific about the columns that we want to keep, and this is why we go ahead and do that. You could use the default, however, you may actually end up with more information than you actually need. And then from there, we're going to then sort by title. And the reason why we go ahead and sort by title is because typically when we use this function, the sorting happens by information criteria. So that's not what we want. We want to, one more time, organize by title. So I'm going to run lines 213 through 226 real quick, and I'm going to show you what exactly the summary table looks like. Right. So enum is right here. This is our summary table. And one more time, we went ahead and we organized by our titles here that we have for each class. In this case, it's 6 classes. And I was saying that if we don't use that sort by function, then this would be all mixed up. If, for instance, our AIC changed and our BIC changed drastically. All right, let's continue then. We are going to add more fit statistics to our table using the mutate function. So one more time, all we're doing now is we're using this LaTeX summary table that we just created, and we're going to be manipulating it using the mutate function because we want to add more information. to that table. And so as you can see, we go ahead and we calculate the CAC, the AWE, the SIC, along with the BF and the CMPK. And so once we go ahead and calculate these using the mutate function, we then are very specific about which columns we end up wanting to use. Since we don't want to technically display the SIC here values, because they are going to actually be used for the Bayes factor value. And so let's see. You run this real quick so you can finally see the full table with all of the fit statistics that we are interested in. Ta-da! So you can see our add-ons, our BF here, and then our CMPCK as well. So there that is. Next, let's create a table that is savable and that is aesthetically pleasing using the GT function. All right, so now that we have our table with all of our fit and information that we would like, let's go ahead and create a table that is savable and aesthetically pleasing using the GT function. We're going to be making this table that's off to the left-hand side here that can be used to use in a manuscript. All right, so let's keep going. We have seen code like this before where we're setting up our primary and subtitle using the tab header argument. And then everything that is in quotations following the MD argument here suggests that whatever's in these quotes is considered LaTeX syntax or LaTeX text. That being said, we can use double asterisks here to italicize whatever is in between them. And then following our column labels, we're going to modify them. And we suggest that our title should be changed to class, which happens. And then our parameters to par, and so on and so forth. From there, we are going to now use new code where we created a footnote. And this footnote is specified using the footnote argument, and then everything in quotes is being read as LaTeX syntax. Okay. And then from there, let's now customize our alignment using our column alignment here. We are going to align everything in center. And so from there, we can tell R that we want all of our text to be in Times New Roman font. But then look, GT can also help us customize our table by flushing our main title here, our table title, to the left. And this is especially useful if you're planning to submit to a journal that requires APA guidelines. Using this whole specification here really does help. From there, you can go ahead and then move on to this table options. You can set our whole font size here into 16 pixels. One more time, just showing you the customization capabilities of GT it's just astounding. And then with row group as column equals to true, this will structure our row group labels as separate columns in the table stub, okay? And then from there, our stub border width is going to be set to 0. It's the width for the vertical border of the table because we don't want it to be visible. That's why we set it to 0. From there, our heading borders, our column labels, and our border of the body of the table are all set to black, which you can see here. And then also we want to make sure that our very bottom border, our very top border, and our background are all set to white, making them invisible. With the tab style option or function here, we can target specific cells and apply styles to them. This is done in conjunction with helper functions such as cell borders, cell text, along with cell fill here. And so one more time, we're just specifying what we want the appearance of our cells to be like. See. When it comes to this alpha here, this is having to deal with the fill of the cells, and it's suggesting that the opaqueness is equal to null, which won't really make it opaque. All right, let's move on. So the location function, or helper function rather, helps us target the cells we want to apply our style to. And in this case, we want to apply it to everything inside of our cells in between these borders. Okay. And then from there, we want to go ahead and move on into bolding our title, our column titles here, our column labels, and that's exactly what this line of code is doing. And then we want to format our decimal, how many decimals appear in our values that are in columns 3 through 7, and we set them to 2. And then any of these cells that have any type of missing information, we are going to set it to a long dash, and you specify this through 2 dashes. All right. Using the FMT underscore number function, you can go ahead and just specify the columns that you want to manipulate. And then using the FMT, so I just want to make sure that you see the difference. It provides a way to execute customizable formatting with raw data values. So just making sure that you are very aware of what these two very similar looking functions are doing. In this case, we are modifying columns 8, 9, and 11. And how we are modifying them is by creating a new function. And so this new function is stating that if X, a value, is less than 0.001, use the less than symbol followed by 0.001. All of the numbers will be rounded to 2 decimal places, and that's what the scale numbers and then X accuracy is. Okay. All right, so for column 10, moving on, using the FMT function, which is different from the FMT underscore number function, we're creating a function that helps us look at column 10 to identify a number that is greater than 100. And so if it's greater than 100, then replace it with greater than 100. And then all other numbers are going to be rounded to 0.01, to 2 decimal places. All right. And then in column, oops, sorry. And then in table style, moving on, we are targeting specific cells and applying styles to them. We are going to apply multiple styles to different cells, so we need to use the list function. We are applying bold to certain values of the BIC, the A, BIC, the CIAC, AW, and CMPK, the base factor, and VLMR. And so we specify the location where we want to apply the style using location function in the cell body in this case. And then from there, in this case, we're going to change for the first one. We're going to make bold the first BIC that is the minimum value across the 6 classes that we estimated. Okay, so it's going to go out 1 column BIC and over the 6 classes that were estimated, we want to highlight the smallest BIAC. Now, if you have estimated, for instance, 10 classes during the enumeration process, you need to change this final value to 10. In this case, we didn't do that. So that's why the minimum value here is 6. And then the same thing happens over and over for the AIBC, CAAC, AWC, PK, and so on and so forth until we reach the Bayes factor. And in this case, we want to highlight a Bayes factor that is greater than 10. Then for the VLMR, we are creating an if-else statement to make R follow a specific rule. And in this case, it states that if the VLMR is less than 0.05, then and the previous is greater than the previous number is greater rather than 0.05, then the VLMR that is less than that point, then less than 0.05 should be bolded. Okay. And in that case, all others should be listed with NA. And that's the same argument that is actually seen for the BLRT, where first identify the BLRT that is less than 0.05. And then if the one after that is greater than 0.05, then highlight the BLRT that is less than 0.05. All right. Now, given all that line of code, you can just run it and you would end up with this beautiful figure here. Okay. There it is. Now, I know it looks gray here, but it won't be gray, so just give it a second. It's just taking its time. It will end up being black. From there, you can go ahead and save that table using the GT save function. Either you can save it as a PNG by adding that PNG extension, or you can save it in a doc. All right, so now let's go ahead and make information criteria elbow plots. We'll be plotting all of our information criteria against one another in a larger plot, and then in separate panels, we'll go ahead and evaluate them individually. How we're going to do this is that we're going to use our all fit table that we just created a little earlier. And so what we're going to do with that table is that we're going to select columns 2 through 7 to make sure that we have these ICs handy. Then we are going to note that our row IDs in our all fit table will now become columns. So these row IDs will now then be listed as columns, which then gives us the number of classes on our x-axis here. And so to continue on and to work on that table to help us create this elbow plot, we're going to be using the pivot longer function, which we used in the proportions table. For BIC through AWE values, we want to name those that cluster rather of IC into index, and we're going to use the name to support function or argument. And then also to cluster those values that are representative of BICs and AWEs across our classes, we're going to also name them IC values, and we're going to use that value underscore 2 argument to help us out with that. Now, using the mutate function, we can make the index names into factors with levels equal to information criteria, and that's exactly what's happening in this set of code. One more time, we're suggesting that our index is equal to a factor, and we have to relist that index as the factor that we want to go ahead and create, and then we want to name its levels off of the AIC, the CAC, and BIC along with the ABIC. Okay. With ggplot, we are plotting our information criteria, and we're requesting that each IC has its own separate color and line type. So our row ID, one more time, is on the x-axis. Our y is our IC values, and this is why we had to name them up above. We have colors, set to index, shape, set to index, group, set to index, line type, set to index. One more time, thus suggesting that each individual IC will have its own color, shape, be grouped, and has its line type. From there, we are moving on to additional support functions. We customize the plot with in great detail. For instance, we can change the size of the points and the widths. And then from there, we can go ahead and then change the breaks to the number of rows in the fit table, which is what we noted earlier, is that we want each of the classes to be listed on the x-axis and the breaks to be associated with those classes. We're scaling in gray color. We're using that cow plot. We've all seen this all before, where we set our title, our subtitle. We also set the X and Y axis labels as well. And we even get into our legend here, and so on and so forth. And if we run all this code, you'll end up with this great looking figure on the left-hand side of my screen here. Now, if plotting against is not what you want, and you want to individually see these ICs, you can go ahead and create a panel. And the panel figure here, all that is different from codes 367 to 403, the only difference here in between those and the following alternative is that final line of code on line 449. This is facet wrap index scale Y free. It's literally one of the only lines of code that is completely different. And so I do want you to note that we are also plotting, for instance, the log likelihood here. So that's one of the reasons why we include column 1 and going all the way through 7. But literally that's the only line of code that's really like different that we are taking and creating each panel. All right, so that concludes this part of our code. So to create our probability plots like this one on the left-hand side here, we are going to use the source function. The source function will help us read an R code from a given file. And in this case, our file that we are trying to read is the plot lca.txt. And here it is. Let me show you it real quick. So this is a function that was previously created to create this plot here, the probability plot. And so all we have to do in this case is using that source function and reading in that code. We then use a function to plot the class probabilities, and we need to specify the output that you want to draw the probabilities from. And in this case, we identified the 3-class solution to be the optimal solution. So then that's why we go ahead and select the output bully 3-class solution as the model name, okay? And then from there, very, very simple, you want to go ahead and just save it. You want to save it, and in this case, we're saving it as a PNG file. And one more time, we're setting the resolution, we set the background to white, we set our height and our width in the units of inches. Okay. All right, so now that we have created this beautiful table, let's start customizing it to make it more manuscript ready. And so the way that we're going to do that now is by first reading in the model. And in this case, We're looking at the three class solution and we're assigning it to model, and then we're creating a title for our new figure rather. And in this case, it's going to be called Boolean probability plot, which we assign to title. And we also create new item labels so that way they're a little more descriptive. And then what's unique and different from our previous one is that we are actually creating class labels. And by now we've already have looked at these different classes that have merged and have come to some sort of descriptive label that can be useful. Now, in the next line of code, we don't want to, or next code chunk, we don't want to edit anything that is in between 511 and 520. And so what is happening is that we are extracting our data in this point in time. So if we go ahead and we want to print this data so I can show you what it looks like, this is the information that we're extracting from our analyses. So we have here in this data, we have our parameter label, we have the category, we have our estimation, our standard error, and then our p-value and our latent class that we're focusing on. Okay, so we're going to filter out to only focusing on category 2. Then using the mutate function, what we're going to do is add 2 new columns. And we're adding an items column and a class column. So let me show you what's going to happen after we run these 2. So the item column is for the parameter, and so the class column is for the latent class. I'm going to pop this open. So now you can see we have 2 new columns. All right, and then we're going to change what is in those 2 columns. We're going to change items into item labels that we previously created. And then we're going to change those classes to class labels. So replacing the 1s, 2s, and 3s with class labels. Let me show you what that looks like. And there you go. These are the modifications that we made using the mutate function. And then now we're only going to be selecting the variables that we want within the plot data. So let me rerun that and show you now what it looks like. So now it's just our estimation, our standard error, our class label, and then those items, and in this specific order. Okay. And that's using the select function. Now let's move on. Let's keep modifying. All right. So to create our line plot, we are going to use much of the code that we implemented before. New to this code is actually the shape function. And in this case, it's suggesting that our classes will all have different shapes. So the shape is dependent upon the class that is selected or that is being reviewed. Okay. And so also something unique is within the label support function, in which we create a function X that wraps strings by a width of 10, because you can see that our item labels here are very long. So you can also change this into smaller or bigger. Okay. Let's move on. We are going to then, you've seen all this before already, so we're just going to move on and save that new line plot using the GG save as we've done before. Okay, and so this is what you will end up with, this figure on the left-hand side. Beautiful. Now let's move on to a bar plot that helps us really look at our probabilities just in a different way rather than using our lines. So there are alternatives that you can use, different visual aids. They're doing exactly the same thing in this point, but they just a different visualization that you might want to use one over the other. Okay, so let's create the bar plot using ggplot. we specify that the items are on the x-axis and that the estimates are going to be on the y-axis. We're going to go ahead and fill in the bars with specific classes. So that means each class is going to have a specified fill. And in this case, you, for instance, have reported low harassment and had high staff, which is dark, and then reported high harassment with low staff, that's like a medium grayish color, and then reported harassment as low and staff is low, and that's a very light gray. Okay. And then from there, we are going to use the geom bar with stat identity to ensure that the data we are plotting is left unchanged. Okay, we want to literally plot whatever data that we have specified. And then we're using the position dodge. In this case, it's the specification that preserves the vertical length of the bars and then adjusts the horizontal position. And then from there, we're going to add error bars to our bars here. And how we do this is by using the geom error bar. And in this case, we are first altering, we're first going to tell our how to go ahead and get the minimum and the maximum of that error bar. And it's by taking the estimate and subtracting by the standard error for the minimum. But for the maximum, we're going to go ahead and just add the standard error. Okay. And then the remaining line of code is to modify that where the error bars are located. So for instance, if you change the position, you can see it shift and then to the left or to the right. And then if you change the size or the width, that will just change the thickness of those lines. And then you can see that we add some labels to our bars here. And then in this case, our labels are actually estimates. And then you can modify where those estimates are located. And then we set our y-axis minimum and maximum to 0 and 1 because those are probabilities listed on the y-axis. Okay. And then you have seen all of this before where we're wrapping our string text. We're also creating a title along with labels for our y-axis and our x-axis. And once you go ahead and run all this beautiful code, you'll go ahead and end up with this really nice bar plot for your probabilities. So that concludes our video on how to create these beautiful visualizations with our code that we have provided. If you have any comments, questions, go ahead and reach out to the Immerse team. Take care, y'all. See you next time.